Hello everyone, my name is Alvaro, and today I will be explaining logarithmic runtimes. So, what does it mean when we say that a program has a runtime of big O of log n? Usually, when we say this, we refer to a log base 2 of n. And to illustrate what this means, here are some examples. As we can see, log base 2 of 16 is 4 because 2 to the 4th is 16. Log base 2 of 64 is 6 because 2 to the 6th is 64. And log base 2 of 256 is 8 because 2 to the 8th is 256. Observing these examples, we can see that whenever we want to know what the log base 2 of n is for any number n, the question that we are really asking ourselves is, how many times do we need to double 1 until we get n? As we can see here, we need to double 1 4 times to get 16, 6 times to get 64, and 8 times to get 256. Now, as a follow-up, what is an equivalent question to the one that we just asked? Well, we can ask ourselves, given a number n, how many times do we need to have n until we get 1? As we can see, we need to have 16 4 times to get 1, 64 6 times, and 256 8 times. Now, let's observe the behavior of binary search. And using this knowledge, let's understand why this algorithm runs in big O of log n. So in this example, we have an array of size 16 with integers 1 through 16. We want to find the number 1 in the array. So we start by looking at the midpoint of the current array. Since the number that we want to find, 1, is lower than the number at the midpoint, we explore the left half of the array. So now the possible places where 1 can be located have been reduced by a half from 16 to 8. Once again, we compare the number that we want to find, 1, with the midpoint, in this case 5, of the current array of size 8, which is represented by the box. And since 1 is lower than 5, we explore the left half of that array. So now the possible places where 1 can be located have been reduced by a half from 8 to 4. We repeat this process again by comparing the number we want to find with the midpoint, 3, of the current array of size 4, once again represented by the box. And since 1 is lower than 3, we explore the left half of that array. So now the possible places where 1 can be located have been reduced by a half from 4 to 2. We repeat this process one last time, and the number of possible places has reduced by a half from 2 to 1. So in total, we have cut in half the array of size 16 4 times to get to the number that we want to find. And as we saw before, log base 2 of 16 is 4. So the runtime of binary search is clearly big O of log n. So what is the takeaway? Whenever we have an algorithm that starts with an input of size n, that performs an operation in big O of one time, in the case of binary search, that will be comparing the midpoint with the value that we want to find, and then the algorithm halves the input size to repeat this operation over and over until the input size becomes 1, then that algorithm is said to be running in big O of log n time.